Now, since we've recently turned to conditionals, I think it's worthwhile to take some time to see how conditionals get treated on fuzzy logic. One of the chief problems is that although conditionals are fully transitive in the binary valuation 0 and 1, that is to say, if we have a string of conditionals of the form if phi1 then phi2, if phi2 then phi3, all the way on to, if phi n then phi n plus 1, phi1 will imply phi n plus 1 just fine. This can't be the way that conditionals work on fuzzy logic, though, because it would allow us to say that the successive removal of grains from a heap doesn't affect its status as a heap, but bit by bit the heap becomes lesser. So we would say if this is a heap, then this minus 1 grain is a heap, then this minus 2 grains is a heap. Well, eventually we're not going to have a heap anymore. And so we want to be able to express these gradations or these changes in the value of our conditionals, and that's what we're going to look at today. So let's start by looking at the truth table for conditionals using our binary valuations 0 and 1. As we've seen, it's perfectly okay to go from false to true or from false to false, but it's in this one line here where we go from true to false that we register the conditional as false. Now, how do we do this on fuzzy logic? Well, there are two possibilities for phi and psi. If the valuation of phi is less than or equal to the valuation of psi, then the valuation of if phi then psi is 1. So that's our first possibility. And that roughly corresponds to our going from either lower truth values to higher ones or going from the same truth value 0 to 0 or 1 to 1. So if we go from a lower truth value to a higher truth value, then the value of the whole conditional is 1. But if the value of phi is greater strictly than the value of psi, that is to say we're going from one greater truth to a lesser one, then the value of if phi then psi is equivalent with the difference of phi and psi subtracted from 1. That is to say, we subtract psi from phi, and then we subtract that further from 1. And the intuitive idea here is just that the greater the leap down in our truth values, the less true the conditional is. So for example, let's suppose that the valuation of phi is equal to 0.99, and psi is equal to 0.98. Then to get the truth of a conditional with these, we'd subtract their difference from 1. So that would be 1 minus 0.99 minus 0.98, which equals 0.99. So it's still mostly true. We're only making a tiny jump. But then suppose that we're going from something that's fully true to something that's half true. So it would be 1 minus 0.5. Well, then that gives us 0.5. So it's only half true. And if you want to, you can run it through to see that if we go from 1 to 0, as we do here on our binary valuation, then that will just give us 0 in our calculations for the value of the conditional. So as we saw with our binary operators, these ways of valuing them work when they're fuzzy values, but also when there are regular binary 0 and 1. And that's just how we do conditionals on fuzzy logic.